guess. So I'll try to make this discussion session as lively as possible. Let me introduce panel members first. Sitting next to me, Mr. Norberto Andrade or Andrade. He's originally from Portugal, but he has been with Facebook. I heard like 6 years now. Or? 3.5. 6 in the U.S. and out of the 3.5 at Facebook. He's based in San Francisco, and his job is public policy, ethics, and privacy at Facebook. And sitting next to him, Blaise, we heard his keynote speech. And sitting next to him, Professor Gary Chen from Singapore Management University. He's a law scholar. His specialty is in tort law, but SMU recently established trustworthy AI program and also Center for AI and data governance. So he is very actively involved in research in today's topic. And sitting next to him, Professor Frederick Heinz, we heard his keynote speech. And then sitting next to him, Malavika Jayaram. He is originally from India, studied in India and also in the US and practiced law for many years, and then came back to Asia, and now she is based in Hong Kong and runs what's called Digital Asia Hub, which is uniquely positioned to think of and bring issues what typical lawyers or practitioners or business people wouldn't really be thinking of. So she is occupying very unique niche area. She joined our conference 2 years ago, and then at the time there was big typhoon in Hong Kong. But this year the weather was very helpful, so she could join without much problem. Although it took time to pass the security check in Hong Kong airport, I heard. And last but not least, Professor Indre Gilliabate, similar. Okay. The way to say her name is not, not easy. She's from Finland, University of Helsinki. She's originally from Lithuania. I guess not many in this room have visited Lithuania. I don't know. But she's one of the first researchers who began studying this area, algorithmic fairness, discrimination issues. And when I began doing research in this area a few years ago, her paper was one of the few that I could find. So her name was very much in my memory, and the way she spells her name, that's also, at least to me, very unique and idiosyncratic. So, and she nowadays she does everything on data. Current project involves data science and evolution. As in the morning session, we'll hear from panel members, give maximum 10 minutes for each, and then we'll open the floor for discussions. We'll hear some feedback from keynote speakers as well, and try to have as much time as possible from the audience. In the morning, there are quite a few excellent questions from the audience, so I'll try to give more opportunities during this panel. Okay, so now I think we can start.
So first of all, I want to thank Professor Ko and his staff, SNU AI Policy Initiative and the Seoul National University for the very kind invitation. It's a pleasure to be here. It's my first time in Seoul, in South Korea, and it's really a great pleasure. I will be brief because I have to. I only have 10 minutes, so I'll deliver some telegraphic points on Facebook's approach to AI ethics, focusing at the end a little bit on fairness. Just a little bit about me. I'm working the privacy and public policy team at Facebook. I work very closely with engineers, data scientists, and managers working on AI. So I have the privilege to see, monitor, and review what they're building. And then I also do some strategic and outreach work regarding AI ethics and governance. So I'll start very quickly with our approach. So let me share a little bit about how we approach AI ethics at Facebook, focusing specifically on how we build AI in a fair and unbiased way. So we take a holistic view at Facebook, and there are three main pillars of our approach. We invest obviously in people that are building the algorithms, our engineers. We also invest in the data that we use to teach the AI, and last but not least, we invest in the algorithms themselves that ultimately represent what the AI learns. So let's start with people. In here, I'll draw your attention to the main three categories of people of this pillar. So talking about people as builders, the ones that build the code, our engineers, but also people that review what is being built, so the reviewers, in which I include myself in. And third, people as teachers, so people that are actually represented in the data sets that we use to train our machine learning models. And I'll tell you a little bit about that. So starting with the reviewers, and this slide portrays the steps that we take when it concerns review of products. And I'm here specifically focusing on products that leverage AI and machine learning, which at Facebook is practically now everything. AI is really becoming a foundational infrastructural component of everything that we do and build. So this is our privacy program. It's a cross-functional review process, meaning that it's composed by different teams. At the core, we have 3 teams that are in charge of monitoring, reviewing, and approving products and new functionalities to be reviewed. So all new products and features that are either touching personal identifiable information or maybe deemed to have privacy implications down the pipeline go through this process. So we have the 3 main stakeholders, which are the legal team that looks at privacy implications globally across the regulatory space. We have the privacy program team, which is the soul of this process, like the heart. They're the ones that are the glue of the process, because they are the ones that bring together all the stakeholders. So all the product managers, engineers, data scientists that are building these features, they are the ones that have the first interface with them and prioritize and schedule the meetings for the other teams to meet with them. They are also the historians of the process, because everything that is reviewed in this process is documented, and they are in charge of that documentation process. And then the third big team involved in this process is my team, which is the public policy team. And one of the main tasks that we have is to engage with the external community in the process. So before rolling out new features and applications for specific features, we brief policymakers, we engage in conversations with privacy advocates and academics to tell them about our plans to build these products and to gather their feedback, to understand what concerns they might have about these products, and then we take that feedback back into the process. So my job is actually to create a sort of bridge between the product world and the policy world, where I go back and forth, understanding how sensitivities and concerns that we hear externally are embedded into the process internally. This process is also a vehicle through which we implement privacy by design principles. So as you can see, it starts at the product ideation phase, meaning that even before engineers start coding, start building the features, we have meetings with them, roadmap meetings, through which they will explain for the next half what they're planning to build. And in that very moment, we start reviewing, we start having conversations with them. And then it goes all the way into rolling out the products, and then we meet again in case we actually decide to deprecate some of those products. So it's a very iterative, ongoing process. And the two other elements you can see here is the external input that we get from other stakeholders, and the fact that this is a very highly documented process. The last thing I would mention about the privacy program is that compliance for us is a floor and not a ceiling. What does this mean? A lot of privacy programs have been established as a legal compliance mechanism with regulatory obligations. This is the genesis of the program, but obviously goes beyond that. So having teams such as public policy, and if we add other teams like marketing and security and communications, there are a lot of other angles and a lot of other observations and comments that go into this review process that go beyond just a strict compliance adherence with laws. So it's important to take into account not only how we abide to laws, but also think about other issues. For example, how is certain thinking about technology evolving in public policy circles, or how can we communicate more effectively with our users about how these products work, or how do we take into account their privacy expectations as a societal developing norm. So these are all examples of considerations that go also into the privacy program process. I mentioned when we talk about people that were the builders, the reviewers, but also they were the teachers. And here, and I think we've learned and heard this throughout many of the presentations today, AI at the end of the day is a product of the data that is trained on. And that data comes from people, from our community. So data in a way is a reflection of who we are, for better or for worse. It's a representation of our actions, of our preferences, of our habits, and also of our biases. So when a machine learns from data, what it's actually doing is learning from us, from people. So and the more I work with product managers, with engineers, the more I understand how AI is actually profoundly human. You can imagine like a child that just absorbs, learns, and kind of emulates based on the data that is exposed to. So the way that we teach humans, we can draw a parallel to how we teach AI and the importance of passing on our values during that learning process. So people as teachers is an analogy that is important for us, and for many reasons. We believe that it's important to know who these people are, who these teachers are, because if AI only learns from a very small group of people, we'll obviously have a very narrow point of view. So it's important to have a diverse set of voices at the table in order to build responsibly AI. And no set of voices will be perfect. We all have our own biases, but it's important to understand that because people generate the data, and through that data we teach AI, it's important to understand our own biases and mitigate them so that we don't pass them along through our automated systems. And with this, I pass to the second pillar, which is the data. So the data that we use to teach AI. And here, I will quickly mention 3 important steps into the privacy program review process that we have specifically for AI and machine learning. And the first step, and I'll go very quickly, is data selection. It's very important for us as reviewers to understand what data should our engineers have access to when building and training their systems. So, and here, what is fundamental is to understand the purpose of the model. What are the objectives? What are the products intended to accomplish? And based on that, we will decide and figure out what is the appropriate data that should be leveraged for training that model. There are also a number of safeguards that we put in place. We look at different sources of data. So for example, if we want to train a machine learning classifier to detect violating content, like hateful content, we obviously, in terms of ground truth, we need to look at data that has been previously reported and has been reviewed as violating content. So we will focus on that specific data as ground truth in order for the engineers to train their machine learning systems and not other data. So we look at sources, we look at types of data, we look at also audience. Data that has been posted publicly will be easier to be granted access to engineers than data that has stricter audience controls. We also have safeguards in terms of de-identification. So we have automated systems that scrub and remove personal identifiers that are not needed to train our machine learning models. So that's one privacy safeguard that we have in place, in addition to the more traditional ones like security and retention limits. The other important step after data selection is data annotation. So most of machine learning model that we do for our products are supervised systems. So meaning that you need to feed the models with data, but also you need to annotate that data, categorize that data, so the model understands what is being trained for. And here we have also a number of important safeguards to ensure that that process is done responsibly and consistently. So you can understand the importance of labeling data. If you want to train a machine learning system to distinguish a cat from a dog, the labeling process would be relatively easy, asking people just to tell if that photo, if that image has a cat or a dog. But when it comes to hate speech or false news, things get a lot more complicated because of the variations, cultural variations, geographic variations of the concept. So it's very important to have a labeling process that, as much as possible, is consistent and it's done in a proper way. So we have dedicated teams that are tasked to ensure the consistency of that process. They are tasked with drafting labeling guidelines that will allow human annotators to have solid and strict points of reference through which to annotate the data sets that are being asked to do. And with that, and there's also risk assessment procedure that we follow when it comes to labeling processes. There's also privacy safeguards that we take in order to expose that data for annotation. I don't have time to go into that, but I just want to really emphasize the point that data annotation is a very important component of the review feature, and there are important privacy safeguards that we have built around it. So you can do a really good job at selecting the right data, you can do a really good job at ensuring the consistency of the annotation process, but that doesn't mean that you have solved a problem regarding eventual or unintended biases. So this is when we get to the algorithms, and we need to check even if we are satisfied with the data selection, data annotation process, there's still the possibility that the algorithm might be learning or propagating unintended biases. So here we get into what we call the algorithmic fairness assessment step. And here I will briefly talk about an internal tool that we developed and that we call the fairness flow. This tool was developed with the help of leading academic and researchers in the fairness, accountability, transparency community. And it basically does two things. It checks the differences of the subgroups that are represented in the data set. So what it basically does is provide a sort of an X-ray anatomy of the data set, so that the engineers that have used that data set to train their models will understand the elements or who is represented in that data set. So it can break down the data set with subgroups of people by, for example, age, gender, location, language, and other variables. So it provides that anatomy of the data set, and it does a second important thing, which is calculates how the algorithm is performing across each of these subgroups, so that the engineer with this tool can understand if the algorithm is doing a better job for certain subgroups of people representing the data set than to others. So let me give you a more concrete example of how we've used the fairness flow in the concrete product. We have a product called the Jobs tool. So people around the world can actually search and apply for job openings with local job employers that post their opportunities in Facebook pages. So we've used the fairness flow to understand how our jobs recommendation algorithm was performing across different groups. So when we use the fairness flow to understand and to recalibrate those algorithms by looking at people by gender, so how the algorithm was performing with men and with women, but also by age, how the algorithm was performing for people over 40 and below 40 years old. So this was a concrete example of how we use this tool to recalibrate before actually releasing that algorithm. So this is all on the technical side of things, but as we've heard also in many talks today, you cannot solve fairness exclusively through a technical perspective. So engineers cannot just build a fairness library, cannot just import an algorithmic bias module and through that just remove biases from model and data. It just doesn't work that way. So tools like the one I just described are important, but they are not sufficient. And this is mainly because fairness is a process. And there are a lot of questions and angles that come from social sciences that need to be taken into account as well. So it's the way that we see fairness is as a sequence of important steps of best practices that we need to follow in order to ensure that our algorithms are fair and not biased. So let me give you an example of what those best practices steps are. So one is to surface the risks to fairness and the hard questions posed by fairness. And here we can have a lot of different fairness questions. One that comes to mind immediately is how do we actually decide who to consider and how to subgroup them? So who do we decide is being impacted by that specific automated decision, and how do we subgroup them? By hairstyle, by hair color, by age, by gender, by race, by ethnicity. So this is an important question of us really understanding the impact of the products that we are building. The other question is in terms of perspective, and I think that Frederick mentioned this in his presentation. Do we strive to achieve procedural consistency across all subgroups that are represented in the data set and that are going to be targeted by the algorithm, or do we try to achieve equal outcomes? So in the first one, you don't care about the outcomes as long as you provide the same resources and you treat all of the people in the same way. So fairness by treatment, but then if we want to focus on equal outcomes, you might need to treat different groups in a different way to achieve then those equal outcomes. And these are questions that are not going to be solved by a technical tool. These are really profound philosophical, sociological questions that we need to take into account when we build our systems. So that's the first step. The second will be to resolve those questions through also a process. And the third one will be to document them. So not only for the sake of transparency, accountability, but also to establish a precedent and not to have to reinvent the wheel every time we build a new machine learning model. So and just to finish, there are many ways that we can have biases in our models. We can focus, as already mentioned, in bias in the labeling process. But then you can also have bias in the algorithm itself, in the way that it's making its prediction. Is it over-predicting a group and under-predicting another group? So we need to take that into account. And even if we are completely satisfied with the way that the labels have been designed, have been figured out and decided, and if we are also confident on and have trust in the predictions that the algorithm is making, then there's also the intervention bias of what actions do we make based on those predictions, on those decisions. And bias can also be an important element there. So we need to take a holistic view and look at the different steps and the different concerns that we have from a bias perspective. And finishing with this slide, there are many questions, and the point that I really wanted to emphasize here is that many of those questions are hard social questions that need the external community. We as a company will not have the answers for it and need really the help of the community. And part of the work that I do and the public policy team does is really to engage with external stakeholders and look for those answers that we can take it back to the work that we do internally. And with that, I finish, and thank you so much for your time.